Hello and welcome back to another, I was going to say recreational programming session. That would be illegal. Welcome back to another compiler from scratch, recreationally. We're still using the word. This should be, what, part 3? Episode 3, I guess, part 4? Where programmers recount from 0. I think today we are finally going to get to tokenizing, lexing, like I've been saying for 3 episodes now. And this is the test file we're going to be playing with. I've got my font size a bit bigger. Hopefully this is better to read on different kinds of monitors. I think I've also got my video settings set up to be, make it back in center of frame there, to be 1080 instead of 720. So it should look crisper as well. Full HD, let's go. I'm not going to record in 4K, I'm not that special. It's only a 1080 screen anyway. So we're going to attempt in this episode to get just these handful of tokens. The only reason I say attempt is because we might have a problem with keywords and identifiers. Identifiers should be fine, but keyword lookup, might have to write some data structures for that. It shouldn't be a big deal. But ideally, in the next 20-ish minutes, we've lexed this, and we can move on to more complicated tokens like integers and string literals and get most of those out of the way. Once we've done that, we can move on to the preprocessor and attempt to parse the driver source file, which shouldn't be a huge deal unless these headers have complicated things in them. We might have to start with a simpler file, like one of our header files or something, but I don't think we're going to get to parsing, or definitely not parsing, oh boy, lexing an entire source file here just yet, but we'll get like the main stuff, right? Again, the preprocessor stuff's going to come later. Include, in particular, is going to be more difficult than define. But as soon as we can get lexing done for most of our project, we're going to move on to the Laye programming language, and I'll show you some of the more interesting things that we're going to do. This is the Laye programming language is something that I've been working on for entirely too long and never really finishing because I've never been happy with the progress that I've made, the direction that I've gone. The more I do dev on it, the more my idea of the language changes. So I go to do refactors, and the refactors kind of fall apart. So I'm trying to take this one from the ground up with all of the most recent ideas I've got. I wrote them all down into a book, thought about it for a few days. A few days may not seem like a lot in the grand scheme of things, I guess, but it's better than a snap of the fingers decision. We're going to do Laye right, and we're going to do it in my nightmare of an environment I've created, creating a C compiler at the same time. Because the goal is that Laye and C will exist side by side. So even if we ditch the C half of this compiler in the future, I want it to be built from the ground up with this in mind, and ideally with our own C compiler for, like, I'd like to just have it for if you're writing your own Laye stuff and you need to dip into a C library for something, and like, that's the easy case. But I would love to just be able to write my own C code sometimes, because you'll want to have C code sometimes to interact with things, to interop. You don't want to just have to do your own C header defs and then migrate a bunch of things over to Laye. Like you migrate the things that are easy to do in Laye to Laye. You leave extra stuff to C because C is still fun. I love C. Laye is like sideways from C. We're going to have very similar syntax, just better type system and a couple new features. And that's really all I want to do with Laye. It's going to have modules. It's going to have, like I said, a couple better types. Like we're going to have a native string type, but it's really going to be like a string view. And I don't know how it's going to handle memory yet. That's the one thing I never solved in Laye, because I never got to executing enough code that it would matter. Because if it's a string view, it doesn't own its memory. What's the lifeline? Like, I don't know. We might have an owning string class. I'm not going to use the word class. We might have like an owning string that you copy into implicitly in the compiler, and then a string view that doesn't own the memory. That might solve my string memory issues, but I still don't have like scoping. You'd still have to manually delete a string. We're going to get into my ideas for memory model later. I don't want to have complicated memory models. I want it to be slightly more advanced than C, with like a defer statement so you can call free. We're not doing destructors probably, because we're not doing constructors either. We're not doing virtual functions. We're not doing member functions. Data is data, and Laye just wants you to model that data better. We'll get into my thoughts on the memory model when we start implementing semantics and stuff. Anyway, let's go lexer some C files. Let's go to lexer.c. We're going to need to do some token work as well, but we're going to start scaffolding out. God, this text is really big for me now. I might even make it like We'll leave it at this for now, and it might go smaller. I'll see what it looks like on my phone screen when I'm done recording it. Because if it works on my phone, then it should work on any phone at this point. We're far enough into the future, right? So let's set up a quick loop here of pushing things into this token buffer. We recently set it up with a vector instead. I think I did that off camera on accident. But we're going to be pushing to that vector of tokens. So tokens.tokens, we're going to call this buffer.tokens or token buffer because we like being verbose on this channel. Cool. My keyboard's never in the right spot. So while not lexer at EOF, the lexer. While we have something we could read, we are going to read. So we'll say layec token. Token. We're going to read into that. I shouldn't have to zero initialize it, but I guess I should, so that if it returns a bad token, we still have some data. So we're going to say layec lexer read token. Right there. Lexer is going to need a pointer to the lexer, and we need a pointer to the token. Then we just, at this point, we might have like an end of file. Well, we shouldn't need an end of file token because we're not at end of file, but we might be after consuming whitespace. I guess we could just use the invalid token, but no, we want to still push invalid tokens so we can track them. So I think we will have a end of file token that we just don't append to the buffer probably. So then if token dot kind is equal to layec ctk, we're going to call ctk our enum name for c tokens because we're going to have a lot of those. I don't mind being that verbose, but like enum names are going to get long. Okay, so layec token EOF, that's fine. If it equals EOF, we're just going to break, not even use the token. Otherwise, we're going to say vector push into the token buffer tokens, the current token. And we're copying it by value, so we don't need it on the stack anymore. It's not like a pointer or anything. Cool. So that's the loop we're going to end up with. Let's go to token.h, because here we're going to need to set up a couple of things for the future of tokens. Love water. If you're not hydrating, hydrate. We are going to type def enum layec token kind. Right. And then for now, since we're not sharing token data between the two just yet, we can call it a c token kind just for easy self-definition documentation. That's what I'm looking for. We're going to want to layec c token invalid as our 0 value. And I like to explicitly initialize 0 just so you know it's my point. And then we're going to have a count up here so we can enumerate over things a bit more easy. It's gonna maybe be a bit funky, the count thing. I need to minimize that. Maybe be a bit funky because we're not going to be enumerating over absolutely every single token, because something else I'm going to do is a multi-byte start. And you're not going to ever use, that's not how you spell multi, you're not going to ever use this on its own. I just like to do this so that we can mark it as the next thing starts 2-byte token kinds. So we can use 1-byte token kinds for single character tokens. And then we can not have to type out layec ctk open paren, right? It'll just equal the open parentheses if I can type that correctly. Same thing for close paren. We can just say close, and it's going to go there. Beautiful. But I don't want to put these in here, well, anything above the multi-byte I don't want to put in here directly. What we're going to do, hair is like falling out again, is we're going to use an X macro style. If you've never heard of X macro, I'll show you, I guess, basically. An X macro style, why don't you like this? It's still just not updating. An X macro style thing for our token includes here. So in C, we're going to say tokens.def is the way we're going to do this. Don't care about your .def files. Close that again. An X macro is just if we were to have like define thing that takes in X, and you could say X of my thing. And then somewhere else you can define x as taking something in, and you can be like enum underscore, we'll call it n, right? And then you could just thing, and then thing, all of these entries in thing are going to expand to whatever the value of x is here, and you can just undef x again. And that's the point of an x macro, is you can carry this one definition around and expand it to whatever you want at like a call site. So that's what we're going to be doing with our tokens. So we're going to say like CTK will be our equivalent of x for this x macro. And we're going to have it take in something like ident. That'll be the suffix we want to append to an enum value, or like it'll be a name that we can print out in like a debug view. And we optionally maybe want it to take values. So let me think here. Do I want a separate kind for other things? I think what we want is, for most of these multi-byte tokens, we want to be able to provide the concept of what it looks like in code without having access to the source code. And for an identifier, you don't really have that. So I'll just call it ident, like that. Same thing for a string literal, so we can say lit string, and it'll just be string literal. We can say the same thing for lit float, or lit real, because it's, I think, the terminology that I want to be using for C here, and Laye. Real literal, and int, lit int would be an int literal. Right, we don't have access to that without having access to the source code and a token, and these are just going to exist sometimes without that. In most cases, when we're two-stringing a token, we're going to get an actual value. But if you just ask for the string value of a token kind, you don't have that. So I guess that's what we're going to do, and I can show you how we're going to use that by, we'll leave these in here because we're not going to need them. We're going to handle those specially. But up here we can then define CTK of the name and a string, and we're going to discard the string, so we could probably just ... it. And we're going to just we're going to expand that to layec CTK plus the n and a comma. So then we can include tokens.def and then undef CTK. So now we're going to have a bunch of enum members that are defined by the name that we provided in the first part here of our whatever here. Now it's going to start switching to C, syntax highlighting, and this is invalid C without that preprocessor define, but that's fine. This may look like it's kind of complicated to design out for our preprocessor restrictions, but it's already doing a define and an include, and we have to implement those to include files and stuff anyway. So by the time we've implemented include and define, X macros are already easy enough to support. They're just exactly the same. So I didn't include an EOF here. We're going to make EOF be, right after invalid, it'll be 1. Then we can do a bunch of delimiters here. We have all of our multi-byte stuff. What we need to parse that first one is some keywords and this identifier here. Before I forget, we also have character literals, litcar, character literal. Okay, so beyond an identifier, we need at least one keyword. And I've recently done the work of putting together a list of keywords. I'm going to see if I can find it real quick in here. Things that aren't on screen for you, I'm sorry. They're all in C++, but I can probably, I'll copy over the C++ code for just using these tokens. Actually, yeah, I'll just do this. We'll make a new buffer here, and we're going to do some manual formatting here. It's going to notice this is C++. We're going to want to turn this into C. But here's a bunch of like categorized keywords. So like here's all the C89 keywords. Here's the ones introduced in C99, the ones in C11, C23, and then some extensions that I started adding but never really got a good list of. So that's the kind of thing we're going to want to do eventually, is get all of this down. And I was going to do it right now, and I might still. If I can like navigate to, I can't, my stuff is broken. ast.hh for C. Because I have a list. I'm just going to have to redo all of these strings. Let's do this one at a time. Let's do all of the 89 keywords, and I'll do the rest off camera. So you can see what I'm doing, but you don't have to go through the tedium. We're going to use some nice select everything, get our cursor on every line. We want to take the string value here, make sure that everything here is just one string. We're going to move that to the end. We're going to want to keep these words and upper them to uppercase. Put the strings at the end and call this CTK like that. And that should get us all of the C89 keywords. So we can don't save this. Again, I'll do the rest off camera here. But that will get us what we care about, which is int for right now. Int is right there, brain hard. So then we can parse the int type. And is there anything else I want to do here other than say that these are C89 keywords just for reference? I don't think so. Is there anything else before here that would be easy to do? I'm going to car string int real. The rest of these I can worry about later. Cool. So then in the multibyte here, the only things that we're going to need right now are braces. We'll add more later, but we have parentheses, we have braces, we have those multibyte ones that we did with the C89 keywords and an identifier. And that will get us, I'm going to close a lot of things here, int plus main plus 2 kinds of delimiters. If we can start lexing that, we've done the easy stuff. We've tested that the lexer works, and that's what I'm looking for. So let's go back to lexer.c, drink some more water. So good. There's our EOF token. That's going to be great. So let's read a token. We need to go into the no preprocess version and let's see. I have a list here. I'm going to show you this part. I went over a bunch of things in my previous foray into a C lexer here of all the things I needed to keep track of in here. So I'm going to leave that open on my other screen just as in case I forget. Easy stuff here. We're going to eat whitespace, set our current position, and then start lexing characters. It's not a huge deal. I'm not looking at anything crazy. I decided to, instead of go with an initializer, just initialize every field. I don't know. But that's the kind of thing I'm going to be referencing there, is my be wary of things for the future. So here's our start location. We don't want to record the start location until after we've eaten white space. And we're going to just call layec lexer eat white space. I'm not very consistent about we're going to do space like that. Lexer. And we're just going to make this a nice fancy static void right above us. And we're just going to say while lexer current car is a space. We have an isSpace function. Is space lexer current car lexer advance lexer. And if we've implemented advance correctly, then this will just eat every white space that we don't want. Advance, allow comments. In this context, yes, I think we will always want to allow comments. We can just pass that in if we need to later. My voice is going to give out if I don't keep hydrating. So after we've eaten white space, we've got our current position here. What we're probably going to do is go ahead and out token location dot offset is going to be equal to, we have to manually calculate the offset, but that's fine. So we're going to say, no, I probably should get, it from this location. Duh, we have a location, or what am I? We'll recalculate the length later. So we'll just say, here's our start location. The offset is going to be, well, the location is going to be start location, no matter what. And we're going to use start location for things like error messages here, so we don't have to do any extra checks. And then at the very end of the function, we need to put a break here. We're going to set the length of our token. Location.length is going to equal, we're going to grab an end location just so we can use it for math purposes. It's going to be end location offset minus start start location offset. That's the length of our token. So then we don't have to do any calculations here until we need to for like some special cases maybe. So let's do, the obvious few is going to be case. Let's do our small things first. For these and this, I think all of our delimiters we can just stick together like this and have it kind of fancy special case, but not really special case. We're going to hit a break. We're going to token.kind equals whatever the current character is. And to avoid a dereference, I'm just going to say cur equals this. Switch on cur so that we can reference cur in here whenever we want. Token kind needs an arrow out token kind equal to current. And we just advance. And that's it, I believe. So we can layec advance lexer true by default. Lexer true, cool. So that gets us those four, easy. The next thing we're going to want to do, and I am going to copy from over here, is I like to be a little bit explicit with my identifiers here. There is a case for just putting an if is alphanumeric in here, but we have a very limited subset of the majority of identifiers and keywords here. So I'm just going to populate A through Z from upper and lowercase plus an underscore, and we're going to build the fast path of identifiers from here. We're not currently going to support any identifier that doesn't fit this case, but eventually we'll need to support Unicode text in identifiers, at which point we're going to want to have a slower path that constructs things in a string builder. I just don't want to deal with that for a while, and I don't think it's going to be something that we run into in any of our code. So I put a label in there, and I think I know why. Yeah, I did that for a GCC extension, so when we get to the extension, I will include that as well. So I don't think there's any reason for me to not just advance as long as we're at a thing, and then copy the string into the string. We don't have to copy it because we're doing a string view. So I think I can just say while is alphanumeric, lexer current char, or it's an underscore because it's not going to be in the alphanumeric. I guess we could make a function called is identifier part, which maybe we do later, but I think we can just say lexer advance true. Well, if we're allowing comments, it'll turn into a space anyway, so like don't worry about that. I think that's our fast path, and then we can just say out token dot string value needs to be string view create of the data plus the length is going to be the start location offset plus whatever our source text is. So we need to say lexer source buffer dot text plus that, and then the length. This is where I might want to pre-compute the length, right? But we can, yeah, we're just going to pre-compute the length here. So this is going to maybe cause problems if we don't rename it. So let's grab it plus this one and call it ident end location. I don't mind duplicating the work for right now. We may want to fix that up in the future, but it's not a huge deal. So we're just going to not even set the location length just yet because it's going to get calculated anyway. So then there's our string slice. So that handles identifiers. And before we do keywords, I'm going to set it up so that we can test this because this is basically a minimal case. We need to be able to display these tokens in a nice, easy to see way. I'm going to do that in token.h and token.c. We are going to just, so here's our source image, right? We're going to have a, instead of returning a string or a string view, because that would require extra work, like allocating memory and having a good concept of a string builder, we're just going to say void layec token print. And it's just going to take in a layec token I guess we're going to need the context. layec context. We're going to print it in a context. It's going to be the same signature as this, basically. Go to token.c, put this at the top here, and we're going to do some trivial printing of a token here. So let's go ahead and grab a lot of what we've got here, because we want the same source buffer for probably doing this and something else. Maybe not even need it right now. Fuck it. Let's assert context and source ID location, and then let's just say get a source image. We're only going to worry about getting source image for right now. So let's printf. We want a string, just a regular old string, for the name of the token. I'm going to put, like, I don't know, a double colon and 2 spaces around it. And we want the the source image of it, in some quotes here. We don't have to quote it. We can do, I like quoting it so that you can see that we got the whitespace correct. Eventually we won't like the quotes because strings. So we'll figure, like, we'll use colors and some other delimiter or something. I don't know. We'll see. So that, I think, is all we care about. So the first thing we need to do then is get the name of one of these token kinds, which we're going to do with another function real quick, token.h. We want a const char layec token kind to string. And we don't need a context, we just need the token kind. And this is going to make use of the same X macro stuff here. Spelled token wrong, that's good. My eye caught something and I couldn't tell what. Token kind, save, cool. So we're going to, if kind is less than, we're just going to use the constant here, multi-byte start. If it's less than the multi-byte start, we're going to special case something, and we're going to return that. If it's not, then we need to switch and do an X macro. Switch on kind. We're going to do the default case of unknown token kind like this, just in case we don't hit something. Then we're going to do define ctk of n and the string value. Say case of layec tk n, return s. And that's all we have to do. We can undef ctk here, and we can include tokens.def, which is actually layec tokens.def. That's what I forgot in the header file. Layec tokens.def. So let's go back into token.h and just make sure that's correct. It'll work, but I like being a little bit more explicit about what we're getting things from. Please update your include path. Huh? Oh, because it missed it stopped looking at C. Rude, first of all, that should be fine. So then this will just return whatever string we passed into the thing. So we can, before we implement that one case, let's const char kind name equals kind to string of token kind, and then we can do a string view token image equals get source image of context and token. We missed this. So then we can do kind name int token image length. Did I call it a count? I need to include string to get that, or util to get our string view. That's C++. Hello. Doesn't util have our string view in it? Layec string view. Oh, because I called it layec string view. That's right. It has a length. Layec string view token image. It's not count. It is length. And then we have a token image dot data like that. I've got things in my eyes. It's always good. Identifier. Okay, that's fine. So now we can print the name and the token image out of here. We've already got the image. The name still needs to work for delimiters and stuff. So here is the thing I think I want to do. We are going to do some static initialization of a character array, and we're going to call that array like what? Single tokens, and it's going to be 256 times 2. We're just going to be explicit that that's exactly what we mean. And it's going to be 0 initialized. And then what we're going to do, readjust myself in my chair here, is we're going to say if single byte tokens sub kind is equal to 0, then we're just going to set that to just make sure that there's explicit casts there, I guess. And then we can return a reference to that. And it'll be a null terminated string. So what we want to do here, sorry, not kind times 2. Kind times 2 equals kind, and then we've got every other character as a null byte, but between those null bytes are the characters that we're looking for here. So we can just return a null terminated string of the character value like this. And that should handle our token kind to string, I think. Because we could return layec, whatever, with the brain's not working right now. We could return this stuff for single character tokens, but we really don't have to, and I really don't want to do that. So that should get us token stuff, and now we can start debugging the lexer. So let's go to the driver. I don't know why I did that. Go away. We have a source buffer. So we're going to then say layec lex. I need to include the lexer to get IntelliSense for that. So let's grab layec c lexer.h like that. So then we can say layec c get tokens. So we need the context and the source ID. So we don't need to get the source buffer anymore. We're done with that. We just want to pass around the ID. From that, we're going to get a buffer. Layec c token buffer. Token buffer. Token buffer is get all these tokens. I doubt this is going to work on the first try, but we're going to set up the code as if it's going to, and we'll debug from there. We want for long I equals vector count token buffer dot tokens. I is less than vector. We want to do I is less than vector count. I is 0. I is less than vector count. I plus plus. So then we can just say layec c token equals token buffer tokens sub I. Now we have a token. Then we can just say layec token print context token, and then printf a new line. Because we're not including the new line in the token, we might want to put it in line somewhere else. This should give us the token. It won't give us the location yet, so I do want to format the location in here as well. So to get the location, we're going to want to print f mod s colon mod lld colon mod lld colon space. Then there's our token that we're printing. So this is going to have token location. I'm just realizing I'm going to have to grab that thing that we wrote last time. So source ID. I do need to get the text. I should have just kept that. Hold on. We're going to be a little lazy here. Undo everything back to the point where we had source text. And then paste everything back. I'm going to do the buffer first, and then get the source text so that we're not like cheating, even though we're not really cheating anyway. So this is going to be source buffer.name. And then something we're going to have to do is go into the context where we've got this nice fancy get line from source. We might just want to have the ability to print because we're going to do it again here. We might want to just debug log why can't I talk? A location. So if I go to, that's what, in source.h, we only have a source.h file. Let me go make a source.c. Layec, not there. We want it to be in lib source.c. We're going to paste this boy here and say include layec source.h. So now we've got this. this isn't going to be publicly exposed, but we are going to like two-string a thing. So let's say void layec location print needs a layec context. We'll have to include that, but it's going to be in the source header, so maybe we don't. Maybe we do just to be explicit. Context.h, I believe. And then we want the layec location. And then here, we're just going to do that printf that we had. So in driver, it's the same thing that we did before. We're going to need to get the source buffer. So back in driver, we're going to grab the source buffer. We're going to put that in here. It's the location dot source ID. We don't need to assert that. We don't really need to assert buffer text either, but we are going to up here, so that's fine. So then we can do in context.c, we can grab the part where we do this, just so that we're not being a pain. So we've grabbed the source buffer. We've got the line from the source information. We're printing the name. And then I think in context, we did some math to get something here. So it's line number +1 and then that. Right. So we can do that here as well. Line number +1 and then 1 plus whatever this is. So that will print a location for us. We can grab this to source.h and just make it a nice fancy thing we can do there. Include layec. Oh, you know what? Hold on. If I go to context.h, we're including source.h, so we're never going to get that context. We're instead going to have to just forward declare struct layec context. We're going to have to do that. And I don't know if you can double type def something, so I might just have to instead say struct Laye context, like that. The downsides of not using a better language, but I love this language, so it's fine. So then in here, we don't have to say struct because it already exists, so it'll be fine. Then we can go into the context here, and we don't have to redefine this. We can remove this entirely. We can then say we want to, we still need the source buffer for maybe something. No, in this case we don't. We will need it later, so I'm going to keep it, but we don't need it for this one thing that we're doing. So what we can do first here is layec location print. In the context, we want to print the location. It's going to get the source buffer on its own. We don't care. We're going to use it for something else down here later. So here we can just remove this. Actually, I want to leave the colon. We're going to go back into the print and make sure that we don't include the colon. That's what we're going to do. So colon plus the format here, so we can remove everything, and now we just have that. And then that's the entire prologue, I think. We're going to do more stuff with this later, like I said. So that gives us a context. So then in the driver, we don't have to print this anymore. We are going to print the colon part, like this. But then we're just going to say layec location print. In context, the token.location. So then we should get, if all goes well, which it almost certainly will not do, if all goes well, we're going to get some tokens. Lots of errors. Fatal errors even. Wow. Really? Use of undeclared identifier CTK4. TK4. CTK4. Did you mean, I did. Oh, because I just didn't, okay. Lexer.c, is that where we're at? No, I think it's token.c, right? We're in token.h, tokens.def, case token.c. Token.c, this should be CTK build. Still got a couple. Undeclared assert in source. Source.c just needs to reference include assert.h. I know I could read a lot of these, but it just kind of helps. Conflicting types for layec location print. Because one of them is a struct Laye context, I know. I might have to just put that in context, but I don't want to. So if I say source.c, this one's the one that doesn't use struct Laye context. So if I do that, does it like that? Conflicting types, no, because we've declared it. Huh. I could put the forward declaration back up here. If I go to context.c, and we'll just, not .c, context.h, we'll just see if the compiler complains about this. I'm assuming it's gonna complain about this. Build. It doesn't complain about that. Great. Great success. Okay, implicit conversion loses into precision. Cur is lexer cur. Oh, that's right. Yep, so lexer.c. We do want this to be an int. Thank you, compiler. Very cool. Cool, cool, cool. Build one more time. How are we looking? One more there. Out token kind equals current. Changes signedness. Is it? Okay, interesting. We're going to explicitly cast then, I guess. I just kind of thought that wouldn't be the case. Laye C token kind. One more build. Looks fine. So if we run this on the driver, do we like segfault? Invalid character in source text. Well, that's not good. It's how did we get there? First of all, if we hit invalid character in source text, we should just advance. Second of all, why? That is a lot of good tokens. A lot of these are invalid. Oh, because we're starting at the hash. I'm doing driver instead of my other thing. Lucky us, though, it is actually doing some work. Most of these are invalid, and they're not, like, all of the names are wrong in here, obviously. But, like, hey, we're actually seeing text that's delimited properly. So, despite it not technically working, this is a really good show. This is very close to what we want, minus the fact that they're all going to be invalid if we go look at them. So, let's clear all my buffers here again. Go to the driver first to just make sure that we're doing things right. Location print colon C token print here is printing this and then this. Kind name C token kind to string. C token kind to string is going to say it's not returning unknown. Is it returning? What is it returning? Oh, well, first of all, for these kinds of tokens, it should be ×2. But for like an identifier, why aren't we getting ident? If I build, does that at least fix that other part? Or is this just a... Okay, it does. We're seeing it for these things, but we're not seeing it for identifiers. Why not? Is it because... Well, again, we're not even seeing that. It's just returning nothing. In our tokens def, we are very clearly doing things here. This should say ident. Maybe I just return... I mean, I think what I wanted to do was this anyway. So if I just ... that, I don't know why it's not working. That's a little weird. That still doesn't work? Really? Are we not? Huh? Oh. Well, I say, oh, it should still be printing something, so something's wrong. But, oh, it's wrong because if kind, let's say if kind is greater than or equal to, you know what? Here's what we're going to do. We're going to take this whole thing and put it in the default case. Let's keep this. So our default case is going to become this. so that we can do a little bit of extra stuff in here. Else, well, not even else, we can just return unknown C token in here again, and that will work. But then we can come over here and say case layec tk ctk invalid. Then we can return invalid C token, and then we can do EOF, which we defined as 1, right? And this can be EOF, right? Beautiful. Now if we build and run, we'll see a lot of invalids and a couple of identifiers, right? Invalid C token. And we won't see the identifiers because I never set them up in the lexer properly. So lexer.c. When we hit an identifier here, we want to say out token kind equals layec ctk ident. Like that. That's what we forgot. Now we'll see some identifiers. Beautiful. That's actually great. What I wanted to do, though, was do this on, I forgot to change this, examples. Really, it doesn't like that. Oh, did I call it test? Hello.c. And that should just give us some actual valid characters here. Cool. We have made some progress. So let's git add dot and git commit. I need to install like maggot or something and use a different text editor. We'll do fun, fancy stuff later. But we're going to commit add basic test proof concept lexing or C, something like that. We'll go ahead and push it. You guys may see this before the video even goes out. Beautiful. Then we just really have to fill in a bunch of extra cases, which I don't want to do on camera. I'm probably going to leave integer parsing and string parsing, or like, you know, number parsing and string parsing and keywords for on-camera stuff. But how long have I been going? This is already 45 minutes long. This is the start of C Lexing, though. So maybe we do C Lexing in 2 parts. We got it all set up here, and we can knock out the rest of the cases in the next episode. Then what that means for us is we can do pre-processing in 2 episodes. Episode, what, 5 will then be a preprocessor episode? That would be cool. And then after the preprocessor is all set up, with as much as I can bear to implement with my limited knowledge of the C preprocessor, we'll finally get on to Lexing Laye, which will be a little bit quicker to set up because we've done most of the grunt work here for C. And then we can get into parsing. We're probably going to parse C and Laye roughly in parallel, work on both of them. But because I have never written a C parser, I've only written the C lexer. So this is my second C lexer. It'll be my first C parser. I've written so many parsers for other languages, though, that it won't be like that different. We'll get, yeah, sometime in the next 4 or 5 episodes, we should be in the middle of, or we should be starting parsing for both programming languages. And that will be cool. We'll end up with the concept of a translation unit, which we're going to have probably in the next 2 episodes, because when we start doing pre-processing, we need to keep all of the translation units state for includes and defines and stuff. So very soon we're going to declare translation unit stuff, and then we'll have modules for Laye. Once we get parsing done, we're also going to probably have a C to Laye step that can convert C code into Laye, and that'll be basically what the import function does. You import a C file, it turns it into a Laye module inside the compiler. That'll be really cool. But we could also use that same functionality to turn a C file into a Laye file and write it back to disk. That would also be pretty cool. That might require some more semantic analysis, so maybe that's a semantic analysis process, not a parser process, right? But, you know, that would be cool. We could also, if I do things correctly, turn Laye code back into C code, and that would be, we could make that the first step of the compiler, basically, is before we worry about actually writing our own backends for like doing IR optimization and writing our own machine code, because we are going to do that. We're going to do an assembly backend and maybe even an object file backend. We'll do LLVM if I'm feeling LLVM. We definitely won't link against it, but we might write LLVM output. We'll have a few different backends. But the beauty of generating C files out of Laye is one, we've proved that we can do it, and two, that's a free compiler backend. We don't have to use our compiler to compile this the generated C code. We can use it to just prove that Laye works. We can run Laye code by compiling in Clang or GCC as just a little bit of a stopgap. So maybe we do that. We have a Laye to C and a C to Laye conversion, so we can convert between the two languages rather freely at human readable scale. Right, that's going to be another important feature, is it'll end up being like a code formatter. That's the second reason we can do it, is we'll get really easy access to code formatting tools. Basically, after we've parsed these files, we're going to spend a lot of time working with them before we even get to code generation, unless I get bored. So yeah, I'll leave you off here. I'll do some of the grunt work for the rest of the lexer off screen, and we'll come back to do numbers and strings. And depending on how quickly we get through numbers and strings, we might even start the preprocessor train. But hey, we are finally making progress after 3 episodes of nothing, basically. Lots of setup with all of my limitations. Hopefully these limitations pay off. I don't want to give up the dream of a C compiler. So, I'll see you guys in the next one. Goodbye.